Good morning, y'all. Nathan Arnold, New Mexico and Arizona Institute. Today we're going to do a quick explanation of osmium crystallization for cavemen. That's me, okay? So, in short, we're going to provide a quick analogy to water, okay? Water goes from ice, liquid, gas, okay? And as we apply heat, energy, to each one, we break its intermolecular bonds, okay? So it takes a lot of heat to get a material to, or it takes a lot of energy to get a material to break its intermolecular bonds, okay? Atoms need energy to break apart, and you can think about that kind of like magnets for short, okay? You can pull two magnets, it takes a little bit of energy to separate them, right? Well, this is kind of what we're doing with osmium. Now, osmium is a refractory metal, okay, which means it is extremely resistant. Due to its very strong bonds, it's extremely resistant to their atoms being pulled apart, okay? Now, between each one of these stages is what's called latent heat. It's your gap. It's your latent heat, okay? And this is also known as enthalpy of transition, okay? Well, as you're trying to break the enthalpy transitionary points through each one and you're trying to get at the phase, osmium has a pretty unique quality called sublimation, where it can go directly from the solid into the gas phase, okay? So what we're in essence doing is you boil water, okay? You boil water and you produce gas, okay? This gas is then floating through the air until it hits something cooler, at which point it would touch and condense. And this is the condensation, is what we all know on the outside of our iced drinks and sodas, right? And so we're just bringing the energy up, or the temperature up, to get it to go into a gas form. We transport the gas atoms onto a condensation point, okay? Now, osmium is really tough stuff. It's really resistant to this change. And so it sublimates. It could go directly from your solid to your gas, and your gas back to your solid, okay? And this is so what you could say is it's overcoming the enthalpy of sublimation, okay? So which means we're putting so much energy into it that it's easier for it to go straight into its gas form than it is to stop at the liquid phase and therefore have to put more energy in it to get it to your gas phase, right? And so same thing with the deposition. Boom, it can slip right over that liquid phase. So pretty much what we're doing is we're heating up the osmium until it reaches its vaporization point, its gas phase, and then we're dropping it. Bam! We're slapping it on a cold surface, right? And we're condensing it, if you will, okay? Now, I know no analogy is perfect, but this should help you understand the basic process of what's going on through our crystallization, okay? So it's solid, we put enough energy, it becomes gas, and we take that energy out of it, and bam, we're back to solid. And you got the beautiful crystal we know as osmium. All right, bye.